a pretty basic question that I think will kind of just help concretize my understanding. So I just want to go back to what you said about the circle, and you have SDRs at different points on the circle. So, and then there was something going on about interpolating. So I have an SDR associated with this point on the circle. I have an SDR associated with another one. And let's say I now land on a point that's between the two that I've never seen. Just walk me through what happens.
Okay. Just imagine you've got a dendrite. Can I erase some of this? I'll erase it. I kind of wrote this up. Here's a section of dendrite. And I have some SDR I want to memorize. So I'll form 20 synapses, let's say. And that's going to represent some SDR. Let's say it's a location SDR. Okay. Now it's coming out of this thing down here or something like that. I'm going to recognize it. As I start moving, so I'm at some location in the world, and as the thing starts moving, what's going to happen is some of these bits are going to go away and some new ones are going to appear, right? Just because that's what's going to happen. That's the way, it's like a bump. It's like a bump of activity, and you're moving the bump in some direction. Well, some new things are added to the bump and some things fall off the bump. It's always a set of cells that are active, right? In a good cell, it's a bump of activity. So there's a whole bunch of cells here that are active, and as you move a little bit, and many of them are still active, but a few new ones, and a few go away, and a few new ones are added, right? It's interesting to think about this, by the way, because this bump can move in many different directions. And if the bump moves in one direction, some bits fall off. The bump moves in another direction, other bits fall off. And so essentially, if there were 20 synapses here, and sometimes there's 20 dimensions you can move in, 20 directions you can move in. But just assume that we're moving. And at some point, I'm adding new ones, and I'm forgetting old ones. Okay. So at some point here, I've now replaced the last of the old ones, and I have all new ones. Does that make sense so far? You're looking puzzled.
Yeah. Okay. So these are dendritic segments.
This is one dendritic segment. These are synapses.
Yes. Okay.
And so there's an SDR up here that's representing location, and there's, let's say, 200 bits are active ones, and as I move, and anyway, this dendrite is going to do is going to form 20 synapses. Subsample this thing, right? It says, okay, I'll subsample this. I'll get 20 synapses. That's good enough to recognize that 200-bit pattern. This is the fundamental SDR method. See what they did. So this is a robust representation of that pattern. If I see these 20 bits active, I know I'm at that pattern. Now, as the location changes, these bits come and go, and therefore some of my synapses will become inactive, but I'll be able to form new ones because some new cells become active up here. The point is, as you move the location bump, if you move it smoothly, these bits will change smoothly. That you don't change them all at once. If I jump from here to here, I can change them all at once, but if I move smoothly, they'll be changing one at a time or so. And which ones change first depends on which way you're moving.
Okay, so as I change the SCR that's up here, so really what's happening, there's a cascade of things. There's my location in space, say of my sensor. As I move my sensor, the SDR here representing that location, it's going to change. And all those synapses are already, they've already formed synapses onto that dendritic segment. But as I change, set of synapses that are active change smoothly with the SDR.
Well, then I can form new synapses because I have new bits of some of these bits are no longer active. So some of these synapses won't be getting any input, but there'll be new bits up here that are active. And so I have the opportunity of forming new synapses.
Okay, but that's on a slower time scale. My question is at inference time, basically. I know the morphology of some object, but now I'm sensing a point that I've never touched on.
I'm getting there.
Okay.
Right. So now I have two sets of 20 synapses here and 20 synapses here. These are, now my argument is the following. Imagine this represents a point in space, and this represents a point in space. Anywhere in between here, between this point and this point, I will recognize that. I will infer it because it'll be some of these bits and some of these bits. In fact, what I argue is if I just form these 20 and then I just form these 20, it'll automatically infer in between. As long as these 2 points are not too far away, it'll recognize any pattern in between these two equally. It's actually inferring, it just says, this represents the entire span from here to here. This dendrite will pick up anywhere along this span.
I see.
So in fact, this dendrite can't tell the difference between this point and this
Right,
point.
so this dendrite simply turns on.
It just says, it gets an NMDA spike. Now, you gotta remember, there's a lot of neurons here. This is just one neuron, right? So there's gonna be other neurons that are doing the same thing. And the population, imagine like it's like the space, the temporal memory. So you got some of the mini columns are active. As you move, so I have two inputs coming in. I have like the sensory input and I have the location input. As they move, the mini columns are going to be changing too. So a single neuron will not represent all points. Right? At some point, this neuron gets turned off and another neuron comes on. It's because this mini column is no longer valid. And so this guy will learn some amount of distance across here. So imagine now you're looking at the actual output of the temporal memory layer. There's some cells active. As these two inputs change, the location, the sensory change, if you go smoothly through space, the active cells here will change smoothly too. And in some sense, you can then represent, you'll have an SDR that represents all points in between these 2 points here. I need to work it out in a visual example somehow. It's a little weird. I know it's strange. My only point is, if you don't sample too far apart, then all the cells will likely spawn over a range of inputs, but collectively they'll still be unique. And I don't need to learn or train on all the in-between points. And at any point in time, I can come back and have some pattern. If it's one of these in-between points, it'll just recognize it correctly. So I don't need to train at every point, and I can infer on new points.